Our offices, our hospitals, even our homes, they're all getting smarter. They can regulate their own temperature, manage their own security, optimize pretty much everything for us. But what if the very thing that makes them so smart also makes them incredibly vulnerable? Okay, let's dive into this. I mean, you look at these incredible structures, right? They're marvels of modern architecture and technology, all designed for peak efficiency and comfort. But behind all that glass and steel, there's a hidden digital battle going on, and believe me, the stakes are way higher than you might think. So, first things first, let's just make sure we're on the same page. The whole idea behind this smart building revolution, it's genuinely fantastic. It's all about making our spaces work better for us. At its core, a smart building uses this huge network of countless Internet of Things, or IoT sensors. These little devices are constantly gathering real-time data, which an AI then uses to automate everything, from the air conditioning to the security cameras. The goal is pretty simple. Use resources way more efficiently and make the building safer and more comfortable for everyone inside. But, and this is a big but, here's the catch. That seamless connectivity, the very thing that makes a smart building smart, comes with a pretty serious hidden cost. It basically creates a massive and often unprotected doorway for attackers. Just think about what that means for a second. Every smart thermostat, every security camera, every single connected light bulb, it's another node on the network. And each and every one of them is a potential open door for someone with bad intentions. And this gets us right to the heart of the dilemma. First, you've got this absolute explosion of devices, which dramatically expands what we call the attack surface. Second, a lot of these IoT devices are built for function, not security, so they often lack even basic protections. So here's the crucial point. An attacker doesn't need to crack the main server. No, they just need to find that one weak link, the one unsecured smart device, and from there, the entire network is basically theirs for the taking. This all leads us to a fundamental and honestly kind of scary flaw in how we currently protect these networks. There's a gap, a huge blind spot that most conventional security systems are completely unable to see. You see, the tools most organizations rely on, things like network access control or NAC, they're designed to look at software and network traffic, but they're essentially blind to the physical hardware layer, what we call layer 1. They literally can't tell if a malicious physical device has been plugged directly into the network. So just how big of a problem is this really? I mean, how many organizations are basically flying blind when it comes to the actual hardware plugged into their networks? Well, the number is staggering, 75%. Yeah, you heard that right. 3/4 of organizations report that this visibility gap is actively getting wider. They've got more and more IoT devices, but less and less certainty about what's actually connected at the most fundamental level. So let's define this clearly. The layer 1 blind spot is the failure of security tools to see the physical hardware plugged into a port. Attackers love this because they can connect a rogue device that just lies about its identity. It can pretend to be a harmless printer, for example, and because the system can't see its true hardware signature, it gets waved right on through security. Let me walk you through just how simple this can be. An attacker just needs physical access to one network port, maybe in a conference room or public lobby, anywhere really. They plug in their small rogue device. That device then spoofs the identity of something trusted, like a printer that's already on the network. The security system, totally blind to layer 1, just lets it in. From there, the device moves silently across the network, a wolf in sheep's clothing, gaining access to everything. And the consequences? They can be absolutely devastating. We're talking about ransomware that locks up the entire building's operations. An attacker could shut down the heating and cooling systems or disable all the security cameras and door locks. This isn't just about losing productivity. In a place like a hospital or a critical facility, this could pose a real physical threat to the people inside. So if the problem is a blind spot, the solution, pretty logically, has to be visibility. It's simple, right? You can't protect what you can't see. So let's explore how this one idea creates a whole new, much more secure approach. The old way of thinking basically assumes that if a device says it's a printer, well, it must be a printer. It's totally blind to the hardware layer. The new way? It's called zero trust hardware access. It trusts nothing by default. It demands to see and verify the unique physical identity of every single device before it even thinks about granting access. So how does this actually work? Well, the system gets full layer 1 visibility.
It analyzes the unique physical layer signals of a device to create a digital twin. Think of it like a unique hardware fingerprint. This lets it build a perfect inventory of every single thing connected to the network. And based on that, you can create super strict rules. If any device tries to connect that doesn't match a known trusted digital twin, it's blocked automatically. No questions asked. And this, right here, is the end goal. Complete granular visibility into the physical hardware layer gives you ultimate control over your network. It closes that dangerous blind spot for good.
And look, the experts behind this research are crystal clear on this point. For any smart building, having this complete visibility isn't just a nice to have, it is the absolute mandatory starting point for real security. Everything else is built on this foundation of knowing exactly what is on your network. Which leaves us with a final and pretty crucial question to think about. We celebrate how intelligent and efficient our modern buildings are, but if they can be so easily compromised at their most fundamental level, are they really all that smart after all?